A more realistic model is the logistic model, is of the form dp over dt equals kp times the quantity 1 minus p over m, where k and m are constant. M is called the carrying capacity. Notice that dp over dt is 0 only if p is 0 or p equals m. P over m is 1, 1 minus 1 is 0. The second derivative, d squared p over dt squared, is the derivative of the first derivative, but we can use the product rule implicitly with respect to t. Simplifying this, we have kp prime times the quantity 1 minus 2p over m. But p prime is kp times 1 minus p over m, so we can simplify this further to get k squared p over m squared times the quantity m minus p times the quantity m minus 2p. Let's look at the phase line. We see that the first derivative is 0 when p is m or 0. The second derivative is 0 when p is m or p is m over 2. We see that the third derivative is positive for any value p from 0 to m and negative for p more than m. For the second derivative, it is positive for any p between 0 and m over 2, negative for any p between m over 2 to m, and then positive again for any p more than m. We can do this by checking the sign of the first and the second derivative. But the sign of the first and the second derivative tell us whether the function is increasing, decreasing, concave up, concave down. We see that at first, from 0 to m over 2, the function is increasing, concave up. From m over 2 to m, the function is increasing, concave down. M is called the carrying capacity or the limiting value. The point of inflection is at p equals m over 2. The logistic model is also an autonomous differential equation. It is separable. We can solve it by separate the variable. We can rewrite it as dp over p times 1 minus p over m equals k dt, and we integrate both sides. We see that on the left-hand side, we can rewrite it as partial fractions, 1 over p plus 1 over m minus p. So the integral is the sum of these two integrals. So the left-hand side is ln of p minus ln of m minus p. This is a minus because of the chain rule. And the right-hand side is kt, and then plus c. We then combine ln. We then flip the fraction inside of ln to introduce the negative sign. So ln of m minus p over p is now negative kt minus c. We then e both sides to get e to the negative kt minus c. And so m minus p over p is a e to the negative kt, where a is plus or minus e to the negative c. We need to isolate p to get the solution. We rewrite the left-hand side as m over p minus 1 equals a times e to the negative kt. M over p is 1 plus a e to the negative kt. We isolate p to get p equals m over 1 plus a e to the negative kt. But when t is 0, p is p naught. So p naught is m over 1 plus a. Isolate a, we get a equals m minus p naught over p naught. The solution to the logistic model is therefore p equals m over 1 plus a e to the negative kt.